Okay. Finding the equation of the axis of symmetry. Since the parabola is symmetric, that's small, right? I can't zoom in more, sorry. That's all I've got there. Since the parabola is symmetric, points on either leg are equidistant. What is that? Right? They have the same distance from the middle, right? From the axis of symmetry. If you're given 2 points that have the same y value, that's very important here, same y value, they are at the same height essentially, we can find the value of the axis of symmetry using the following formula. Note this as well, that the axis of symmetry coincidentally also will supply us with the x value of the vertex, right? So here's the formula. It's nothing fancy, but this is the AoS essentially. We take x1, x2, right? X sub 1, x sub 2. Make sure you add that first. The brackets are courtesy. Whenever you see a fraction and there are operations happening either on the numerator or denominator, you need to do those first. You need to perform those operations first before you divide. So a lot of students will go this plus this divided by 2. The calculator will only divide this last number by 2 and then add that answer to the first number, which will be wrong. Okay, so you got to watch out for that. X is the axis of symmetry. Which is essentially the x value of vertex. And the x1 is the x value of point 1. X2 is the x value of point 2. You decide which one you want to call point 1 and which one you want to call point 2. It doesn't matter. So I'm essentially not going to show you anything new. I'm just going to maybe unpack axis of symmetry a little bit more. So this would be the equation of the axis of symmetry, right? You usually say x is equal to a number, and that number can be found using this formula if you don't know what the vertex is. So example, determine the equation of the axis of symmetry of the parabola below. Let's put arrowheads on there. And let's make a note, right? This point and this point, we know they're exactly opposite each other. How do we know that? Because they both have a y value of 11. They're on the same height. They're looking right at each other, eye to eye, right? So I'm going to use probably a red pen or something just to indicate the axis of symmetry. Where would the axis of symmetry be? It would be going right down the middle in this case. We know it's there. But right now, let's assume we don't actually see this graph. I'm just giving you points. And then we're going to bring that all back to this graph to visually see what's happening. So what I like to do is I like to say, okay, there's a distance between these 2 points. There's a distance between those 2 points, and I know that from this point to the center, it's going to be the exact amount that's going from the center back to the other point. Right? That's a given. So that is absolutely critical for this to work. Okay, so let's go even further. It takes 1, 2, 3, 4 boxes to get from the center to that side, it will take 4 boxes or 4 units to get to the other side, right? So 4 and 4. Okay, so to get the axis of symmetry, so using -211 and 611, if this is our point 1, then this value right here will be given the x1 label, and this point right here will be given the x2 label. And so here's how I find my axis of symmetry. X is going to be x1 plus x2 divided by 2. It's always divided by 2. You're basically finding the average between the two. Okay? And you know what? I'm going to use square brackets just to indicate the top has to happen first. So let's go ahead and do that. I'll just show you here. Second quit, right? Gets you to your home screen. I'm going to go -2, negative, not minus. It's the first number. -2 plus 6. That's 4. I think you all knew that already. And now you can go 4 divided by 2, and that's 2. Let's see if you don't do the top first, watch what happens. -2 plus 6 divided by 2. The answer will be 1. Why is that? But because of bed mass, right? It'll divide. It will go 6 divided by 2 is 3. -2 plus 3 is 1. So you got to watch out. Do the top first, find your answer, and then divide. You've been warned. What if we use the other 2 points here, these ones, using 0, 5 and 4, 5? Because again, I will highlight them with the same, just a yellow highlighter here. We know that they're right across each other because, right, they're both at the same height, the same y value. Okay, so we can still say, hey, this is x1 and this is x2. Before we even calculate this, the axis of symmetry hasn't moved, right? It's still where it is. We're expecting it to be 2, right? So I'm just going to show you the obvious, right? So it's going to be 0 plus 4 divided by 2. 0 plus 4 is 4, divided by 2 is 2. Ta-da, right? We've got our axis of symmetry. Therefore, the axis of symmetry, if a question asks you, hey, give me the axis of symmetry, it is an equation, is x is equal to 2. This is the axis of symmetry, which is this line right here. So when you don't have a graph and just given points, if you notice that they are at the same height, it's just as easy as that. Add up your x values, divide it by 2. You've got your axis of symmetry right there. So you know that the vertex, the coordinates of that vertex would be 2, and in this case 3, right? 2, 3. But you just found the x value of that vertex. I'm going to make this homework. I basically ask you to do the same thing. Again, find the axis of symmetry given those 2 pairs. And notice that, right, they're both at the same height. Or else this is all down the drain, guys. You can't do this unless they are at the same height. Okay. So let's keep going. How else does this work? How else will this help us? Page 13 at the top. 13 at the top. Determine the missing x value. So what do we have here? We have a point. We have another point. Oh, I see something here. They are both at the same height. That's interesting. So I know they're right across from each other. All right. And a vertex of 6, -10. This right there gives us the axis of symmetry, right? The vertex gives you that. We call it x, right? In this case, when you use the equation, that's x for us. Okay. So using x is equal to x1 plus x2 divided by 2, like using that formula, we will find that missing value. We will find question mark. Because I will make this my x1. I will make that my x2, which in this case is unknown. And that right there is x. Right? The vertex gives you the x, the axis of symmetry. So it's just a matter of substituting and solving here. So we'll put the 6 in for x. Okay. Let me see here. Yeah, I'll put the 6 in for x. I know that x1 is 3. I don't know what x2 is. All of that divided by 2. And here's where arithmetic comes back. We've done this since grade 7, 8, right? Something like that. COVID kind of threw stuff out. So, but basically, you want to slowly isolate x2. That's what you want. You want that to be isolated by itself. So what I do here is I'm going to take this whole thing and multiply that by 2. Why am I doing that? Because I first and foremost want to remove the 2 that's dividing. So what you do to one side, you must do to the other side. Okay, and so that allows us to cancel these out. And so you're left with 12 is equal to 3 plus x2. And what happens next? 3, right? I want to get rid of that, so I'm going to go minus 3 on this side of the equation, and also minus 3 on the other side of the equation. That turns this to 0, right? So x2 on the right side is equal to 9. So it goes back and forth. You can use points to find the axis of symmetry, but you can also, if you have one point and the axis of symmetry, you can go back and find the value of another point. Oof, time is flying. So I'm going to pause here for a bit. I just had this in there to, sometimes I get students to think about this part, but this is coming back in the next section that we're doing. So I'm just going to pause there for a bit. So let's go over to 15. And we already have talked about the vertex form. We have talked about the vertex form already. You've seen it, but now we're going to zoom in a little bit more. I know you're excited. You can't wait to hear this, okay? Recall the general form has no brackets. It looks like that, but the vertex form provides you with the direction of the opening, right? What does it do? It tells us the direction of the opening, the width, and this is new, number of x-intercepts, as well as the vertex. Right? That is new. It tells us the number. It doesn't give us the y-intercept, guys. It doesn't. right? So just forget about it. So this is in general what it looks like. And we use H and K because those are going to give me the vertex. Where A determines direction of opening. Determines direction of opening, right? Positive up, negative down, 15. Right? Nothing changes there. And determines the width. Determines the width. And that would be narrow, normal, and wide, right? So that still stays the same. Nothing changes there. The vertex, watch this. You take this whole thing and you plug it in there. But when you bring it out of the brackets, I think I already told you, we're gonna, if it's negative there, it's gonna go plus H, right? Plus H. And K, you take the whole thing for K, sign and all, and you insert it there. So now you actually have the coordinate of the vertex, right? So I will just say, put an arrow up there, change the sign from equation. That's how I shorten equation, right? So change the sign of the equation, whatever is in the equation, right? You change it when you actually state the vertex and vice versa. If you put it back in there, you change it back, right? K does not change sign. K stays the same. You will notice if you take pre-cal or applied next year, some of you might challenge pre-cal, that's fine. When you take stuff out of the bracket, it changes the sign, right? You put it back in, you take it out, so that's what it does. Okay, here we go. Let's just look. Vertex form, how do I know? Brackets and a number trailing. How do I know this is vertex form? Bracket and a number trailing. How do I know this is vertex form? Bracket. Oh, there's no number trailing, Mr. Dixon. What's up with that? There is plus 0. It's still trailing. We just forget about the 0, right? But these are all in vertex form, and they look ugly. I know some of them, but that's fine. Direction of opening, down. This one would be down because that right there is A, right? Whatever's in front of the bracket, so A is negative. The width is normal because A is equal to 1. I'm going to put that in brackets, the explanation as to why I said that. The vertex, for 5, because I remember in my cheat sheet, I somehow take H and I take K and boom, it's there. It's positive here, so we need to change it to negative. Yeah. And you can verify this using your calculator. If you want to find the vertex using your calculator, those are the coordinates you're going to get. Y-intercept, 5, right, Mr. Dixon? 0, 5, right? Because you told us no. So you got to use second, trace 1, x is equal to 0. That's how you're going to find it for all of them. You're going to have to find it that way. So we're running out of time. So what I'm going to say is this. I want you to fill this table in. That's your homework as well. So the axis of symmetry and this table. Let me see. I'm just going to peek here. Just going to peek. And 19. What? You got to be kidding me, right? No, I'm not. I need you to be good at so there's a bunch of equations, different forms, and you fill in the characteristics of it, okay? do as much as you can so we can continue with this tomorrow. Okay, guys? I will post the answer key